Hey there everyone, this is Zare, and welcome to B-Side. Alright, so just as a quick overview, Advent of Code is a special event that's been running for, this is the third year now, and every day they release a new programming challenge for you to solve. Each problem comes in two parts. The second part is usually a twist on what happened in the first part. This is a lot of nerd stuff. So, we're going to be kicking this off. As the title indicates, I'm going to be writing in C#. It's a language that I hadn't had too much exposure to before this week, so I wanted to make sure that I refine my skills with it. Before we dig in, I did spend some time in advance creating a very simple framework, so I'm going to go through that line by line here. So of course we've got the program class with the main function. This is where the program is going to start at. We're expecting 3 arguments when we start this up. Those are the year, day, and part of the puzzle. And with that information, we're going to solve the puzzle. The solve function prints out bunch of information, so which puzzle we're working on. We've got some tests written up, which we'll go over to once I reach the puzzle class. It'll get the correct input, which we'll find over in these input files. And for fun, we've got a stopwatch, which is going to time our solution. And we solve it. This is just how we figure out which puzzle we need. So we take that information we got when the program started, and we parse it into a file name. When we run the test, we run all tests attached to that puzzle, and if they all pass, then we keep going, and if they don't pass, we let us know which tests are failing. And then just a simple output. We need this read key function here. All that does is pause the program and waits for user input. If we didn't have this the way I'm running it, then as soon as we printed out the solution, the shell window would close. So we put in that little pause just so that we can actually read it. And the puzzle class, we set up a couple of very simple test cases where we put in the input, what we expect out of it, and which part of the puzzle we're testing. Some abstract functions here, just so that every puzzle knows that we need to solve. Every puzzle can set up their own test cases, and they can run their test cases. All right, and that's that. So I have not seen what is going on this year yet, so this is going to be a complete surprise. Let's dive in. All right, inverse CAPTCHA. Right before Christmas, one of Santa's elves calls you in a panic. The printer's broken, we can't print the naughty or nice list. Oh no! By the time you make it to sub-basement 17, there are only a few minutes until midnight. Big problem, she says. Must be almost 50 bugs in the system. But nothing else can print the list. Stand in the square quick. No time to explain. Convince them to pay you in stars. Alright, so every time we solve a part, we're going to get 1 star, and this is also going to affect that map we saw right here. Click start with solving puzzles. Okay, digitization quarantine written in LEDs. The only door is locked, but it includes a small interface. Restricted area, strictly no digitized users allowed. Does not explain that you may only leave by solving a CAPTCHA to prove you're not a human. That's an interesting twist. Apparently, you only get 1 millisecond to solve the CAPTCHA. Too fast for a normal human, but it feels like hours to you. CAPTCHA requires you to review a sequence of digits and find the sum of all digits that match the next digit in the list. Next digit in the list. This is circular, so the digit after the last digit is the first digit in the list. 1122, which is the sum of 3. First digit matches the second digit, and the third digit matches the fourth digit. Sum of all digits that match. Okay. So what this is saying is every time we run into a duplicate, add that up to the running sum. And also the last digit will check the first digit. Each digit, all one, matches the next. Yep. Which is 0 because there are no loops. Which is 9 because the only digit that matches the next one is the last digit 9. That's the solution to your CAPTCHA. Okay, so first of all, let's get our puzzle input. That is a lot of input. Year 2017, here's our input. Did I get that all? Yeah. Okay, it's all one line. And then let's grab our test cases. First one, don't need that. Expect an output of 3. And 1, 2, 3, 4. Let's not copy that. Equals 9. So there are our test instructions. So what are we going to need? Well, first we need to read each number in, and we need to be able to check the next number in sequence. So let's make a function here. Well, first of all, let's get the input. What do we need to output? Figure that out in a bit. Okay, so we're going to have one long string. So let's make an array ints. Oh wait, this is going to be an array of strings first. So we take that input. Split it on nothing, so it should break each character down into a single character. Let's make that a list. So we don't know how many there are going to be, so we can't straight up do an array. in input array. List numbers dot add in 32 parse. So that will turn our string into a number. All right, and first of all, we parse our input. And then let's just debug what we've got so far. So for each number in numbers, all right, let's see what we got so far. Build errors. Why aren't you liking that? Empty character literal. Okay, first of all, you don't like that, and second of all, you don't like test cases. You shouldn't care about that. What am I doing wrong? Oh, the part, that's why. Okay, that part's happy. You don't like the empty character. Hold on. Let's see if we get split. So we want to break up each character. Old Stack Overflow. Ah, to car array. That's what I want. These are going to be cars. Spelled, and you need to be a function. All right, what's your problem here? Ah, previous line's the problem. Card to string. Simple hack. Now let's debug. All right, our tests all passed for 2016 day 3 part 2. So let's switch over to what we're actually working on. Okay, we're failing as expected. And 1122, 1111, 1234, 9121, 219. Yep, perfect. So get rid of our debug. So our input's looking the way we want it. And so we need to get sum of sequential numbers. All right. Now for the bulk of the problem. List of ints. We're going to return a single int. Okay, so we need to find out if each number's next one is a match, and if so, we add it to the sum. So first of all, we're going to need a sum. And not going to want to do a for each here because we need to keep track of the index. So we're going to do a normal for loop. Is less than first dot count plus plus. We'll figure out how we want to handle the end case after. So we're going to do this for each one. So if numbers I equals numbers plus 1, sum equal to some numbers I. All right, so this should check if for each number that we've got in the list, if it's equal to the next one, we are going to run into a problem with the last array because the last one in the list. Because the last one, the next one, doesn't exist. So let's just do this. And then if can we do -1? We'll figure out. No, we can't. We could probably actually extract this out to a function, but for now let's just leave it as is. Okay, so we expected 3. Right, we're not sending our output. Oops. Test all passed. And it says our solution is 1141. Let's check that out. We got it. Part 2. Notice a progress bar that jumps to 50% completion. Apparently the door isn't yet satisfied, but did emit a star's encouragement. Yay. Encouragement. Instead of considering the next digit, it wants you to consider the digit halfway around the circular list. As if your list contains 10 items, only include a digit in your sum if the digit 10 over 2 equals 5 steps forward matches it. Fortunately, your list has an even number of elements. That's good to know. Okay, so here's our new test input. Oops, we still got our code running. Stop that. I'm counting 5 cases here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 2, 5, 1, 2, 2, 1. 2, 1, 2. Oh, I overrode that one, that's why. Let's restore that test case before we move any further. So you are 6, you are 0, 4, 12, 4. Okay, so what we need to do is figure out this. This is the difference. Could also do an int. So instead of checking, are these two equivalent? If so, then add this. We could just say, if these are true, give us the number. If they're false, then give us a 0. Let's do that. So if equals B, return A, return 0. So if numbers sum plus equals some contribution make sure we haven't broken anything. Ah, the new tests are broken. We're not ready for you guys yet. Zero. Oh. Yeah, 9 is what we expected. Okay, good. Could probably do it in here, but let's just keep moving. I'll explain what I was thinking later. Get. Okay, so we need to make sure that numbers I there's plus halfway. So int half size numbers dot count. 2. Alright, so for int I equals 0, less than half size, less than or equal to? Less than half size, yeah. Sum plus equals get sum contribution and for the other half of the list less than numbers dot count. Hold on. If it's checking halfway across, then this should just be double. All right, let's run through one of our tests here. 1, 2, 1, 2 should get us 6. All right, so sum of halfway, so halfway is 2, so 0 plus 2, that's 1 and 1. That gives us 1, 2, 2. Let's see if we can cheat. Test all passed. Oh, because it's 11 for 1. But it does mean our part 2 tests pass. So that's reassuring. Also 1141? This seems suspect. It's not the right answer. Oh, because I'm not changing which test I'm running. Derp. All right, let's get our switch statement running. we get the sequential sum. No, that was that. Alright, let's try that. 950, that's better. Awesome. One puzzle down. Ooh, shiny. Should see what happens if we only do partially complete it too. Okay, corruption checksum. Walk through the door, glowing humanoid shape yells in your direction. You there! Your state appears to be idle. Come help us repair the corruption in the spreadsheet. If it takes another millisecond, we'll have to display an hourglass cursor. The spreadsheet consists of rows of apparently random numbers. To make sure the recovery process is on the right track, you need to calculate the spreadsheet's checksum. So we will open... That is not a link. For each row, determine the difference between the largest value and the smallest value. The checksum is the sum of all these differences. For example, given the following spreadsheet, 5195, 753, 2468. First row's largest and smallest values are 9 and 1, so that's 8. 7 and 3, 4, 6. Spreadsheet's checksum would be 8 plus 4 plus 6 equals 18. Okay. Here's our input. Before we go, I didn't check these cases. And we got our answer. Oh. I remember to close my programs. Well, test still passed. So let's commit our changes. We're done with those two. Oops. All right. So our checksum is going to be 18. Straightforward enough. We are still working with numbers, so we don't need to consider the, well, what we want to do here. First of all, let's just confirm that we can get a max and min of array. That gives us the index. Okay, so we can just do max and min. input. String array. Input.split. I'm going to split on the new lines. So we are going to need to further split those up. It's going to be a list of int arrays. Now, looking at this input here. Oh, these are all tabs. Perfect. No leading tabs. Okay, so we don't have to do any tricky checking here. All right, so list int number arrays. Enough. So entry dot split on the tab symbol. And for each, I'll do my types. Yeah, this is going to be a string. Right, we can't define these, so hold on. No, we can. No, we can't. List.add int32.parse number. This is now a list of lists. And let's debug our input. Let's give that a spin. Right, we have to actually call our parse input. Unhandle exception. Input string was not in correct format. Oh, we're not breaking this down. That would do it. Okay, so numbers. Oh, wait, hold on. It should be for each entry, yeah. Number list. That should be correct. So what's going on here? Console right. Just in case we got any naughty symbols in there. Okay, so it's giving us the whole thing, the whole line. Because this is checking, what? Okay, this is checking for the n. Input array. Okay, let's make things a little simpler. So now I did this over here. Okay, so we're going to use a regex, and this will find just the numbers. Each. What is going on here? This is going to split them up. It splits them up by line. So we've got each line. And for each line, we're going to split those up onto tabs, right? So we need it up here instead. And we need to include regexes. I'm just all over the place right now. So now it shouldn't be up here because this gets our lines. This is where we're trying to break them down. Can't extract that. Don't need to set that every time. Text. So that gives us the matches. So that'll convert the match to a string, that should turn it into a number, and that should add to the list. Okay, so we're not getting an end one day. Leave that out. But it looks correct otherwise. Yeah, okay, I didn't have a closing. So that's perfect. All right, we've got our input. Private, we're returning an int. Max and min. And this is going to give us a list of ints. Number in actually, hold on, we don't even need to do that. Okay, rather than do this with arrays, let's just quickly write up our max functions, our min functions. Store max. Just in case we get an empty list, we're going to return 0. Otherwise, we're going to assume that the max number is the first number in that list, and then we're going to go through the list and see if we can prove ourselves wrong. List. Where do you come from? All right. So that's going to get us our differences. Hello, Golden Spider and XPD23. Welcome to the stream. I know, best graphics. What is Advent of Code? Advent of Code is a yearly challenge starting in 2015 where each day you get a new programming puzzle to solve, and each puzzle comes in 2 parts. One is a fairly straightforward puzzle, and the second is a twist on the first part. All right. So where was I? So we can get our differences of max and min. So now we need to do it for an entire list. List, int. That's when we're going to get those puzzles. You can find them on adventofcode.com. My naming is all over the place right now. $1 million prize for solving all the puzzles first. No, but you do get prestige and 100 points. Redeemable only for Advent of Code bucks. There's currently nothing in the Advent of Code store, so just hold on to those. List of number lists. And checksum equals 0. All right, let's go. Failed. Expected 18. We're still not putting out our output. All tests passed. 43074. It's not the right answer. The answer is too high. Apparently random numbers. Make sure the recovery process is on the right track. I need you to calculate the spreadsheet's checksum for each row. Difference between the largest value and the smallest value. The checksum is the sum of all of these differences. Okay, what went wrong? The difference of max and min. So we're getting the difference between the max number list and the min number list. So we looked at our puzzle. We could probably figure this out by glancing at it. Okay, let's put in a breakpoint. If I only knew how. Pressing F9. Count equals 4. What went wrong? Everything. List count equals 4, 5195. Okay, so this is the test. Continue. 3, 4. Scene. So the first one has 15 numbers. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, we're missing one. No, I just forgot the 0 index. 16. These are all 16s. Okay, this is not helping. Age 12, 0, 498. Now this looks like it's heading about the right way. There's something off somewhere. Oops. As much as that statement helps. is less than or equal to 0, return 0. This number. So why is our test pass, but this doesn't? Just make sure I copied it correctly. I tripped over the number or something. Part 2. Great work. Looks like we're on the right track after all. Here's a star for your effort. Or the program seems a little worried. Can programs be worried? Based on what we're seeing, it looks like all the user wanted is some information about the evenly divisible values in the spreadsheet. Unfortunately, none of us are equipped for that kind of calculation. Most of us specialize in bitwise operations. Evenly divisible values. So, divide by 2. Is it? It sounds like the goal is to find the only 2 numbers in each row where one evenly divides the other. Oh, interesting. Okay. That is where the result of the division operation is a whole number. It would like you to find those numbers on each line, divide them, and add up each line's result. For example, given the following spreadsheet, so it should be 8 and 2. In the first row, the only 2 numbers that evenly divide are 8 and 2. The result of the division is 4. Second row, so we've got 9 and 3, so that's 3. The third row, the result is 2. 6 and 3. The number of the results would be 4, 3, 2, 9. Close our code. Nine, 4, 7, 3, 3, 8, 6, 5. It's supposed to come out as 9. Okay, so our input's still parsing what we want. So our switch here is switch part 1. That down. Let's get sum of divisibles. Okay. So, I think the only way we're going to figure this out is with an n squared operation, where we have to check each value in the list, and then from that check every value in the list again to see if it's divisible. So, hold on, what is the number that we're looking for? So we want to find the division. Okay. So we need to find the two numbers that divide into each other, and then okay, so get division, divisibles. We'll get back to that in a bit. So we need the list of ints. For each number in number list. For each int divisor in number list. Hello, Bryant. Welcome to the stream. No, we're not going to want for each here because there is the scenario in which, let's say we take the first number is 9. If we keep searching through the list as we've got set up right now, then the first number is going to check against its 9, which is divisible by 9. So our answer is always going to be 1. Let's switch this over to index. Number list dot count. J is less than number list dot count. If I equals J, continue. So that will skip us from checking the same number. But it won't skip us from the case where there are 2 9s legally in that list. If number list I mod number list J return number list I divided by number list J. Okay, so for each list in list sum equals 0, sum plus equals get division of divisibles. Alright, let's give that a try. Filled in part 1. Expected 9, got 18. You should not be expecting 9, you should be expecting 18. Because this is 2. And while we're here, let's change our parameters. Test all passed, 280. Got it. I forgot to check what happens when you only got 1 star. Okay, last puzzle of the day. Spiral memory. You come across an experimental new kind of memory stored on an infinite 2-dimensional grid. Each square in the grid is allocated in a spiral pattern starting at a location marked 1 and then counting up while spiraling outwards. Okay, so we've got 1, and then we spiral like this. And then we keep going. This is very space efficient, no squares are skipped. Requested data must be carried back to square 1. These are the only access port for this memory system. By programs that can only move up, down, left, or right. You always take the shortest path, the Manhattan distance between the location of the data and square 1. Oof. Okay, so data from squared 1 is carried 0 steps since it's an access port. From 12 takes 3 steps, 1, 2, 3. 23 takes 2 steps. 1024 must be carried 31 steps. How many steps are required to carry the data from the square identified in your puzzle input all the way to the access port? Our puzzle input is 312,051. Before we get onto this, let us commit our code. Okay, so we could simply create a spiral large enough to contain this number and then see how we can get to the center point from there. Is that the best way? That's probably the only way. Are there any little tricks here? So square 1 is 1, square 2 is 9, and this is 25 elements. Okay, so we're going to keep getting a square of an odd number. Okay, so we can take this input, find the smallest square that's equal to or larger than this input, and then we can start creating the spiral out of it. And then we just need to figure out the index of this and the distance from the center point. Well, may as well be consistent. And let's get our test cases. Okay. Add. Oops, let's make our actual test case object. Three, 10, 24. So you're expected to be 3, you're expected to be 2, and you are expected to be 31. Private int parse input. Really simple parse function. So to solve this, first of all, we need to get our input. We don't need to depart. So array size. Yeah, array size equals get size of array. I'm gonna call it a map. Okay, so then we need a map. Oh, how did you do this one again? Okay, let's take a look. Hold on. I think there are multi-dimensionals. That's what I'm looking for. Yeah, equals new int. Okay, that's what I'm looking for. Map size, map size. So this will get us a multi-dimensional array that should be large enough to contain our spiral. All right, and then we need to search it. Now, if we make our spiral, we're only making it to the target number, and the target number should always be on the outer layer. So that's going to simplify our search a bit. Let's get rid of these. So what do we need to do for that? Well, we need to find the index. So point, where was the point stored? Using system.drawing. Number index equals get target index map target number. Number index dot x plus number index dot y. No, that's not quite it. Because if we're in row 0, yeah, that doesn't work. And midpoint. Math dot ceiling. So this is going to divide this number, which is always going to be odd, by 2 and round up. So if we have, oh no, we want to floor because 0 indexing. So if we have an array of size 5, so we've got index 1, 2, 3, 4, that's 5 numbers. then it's going to find the halfway point of that size, so 2.5, round it down, so we're going to get index 2, which is the midway point. But why don't you like floor? It's the largest integer less than used between the following methods: math.floor decimal and math.floor double. I'm going to come back to that one. Math.absolute, number index is midpoint. And return it as a string. All right, so this will find the difference between x and the midpoint. So in that example here, if it's 0, then we're going to be at -2. And since we only care about the absolute value of it, we get the absolute value. So we'll get +2, and we add the difference. Doesn't have, okay. So this is going to return int, get needed size of map. Okay, so int for int I equals 1 is less than, let's just do true. This is going to make us go through all of the odd numbers. We're going to find the square of them, and if it's bigger than the largest number. So if I times I is greater than or equal to the largest number, right, get target index. So point get target index int map int target number. Int I equals 0, I is less than. Oh, how do I find the sizes of these multi-dimensional arrays? Oh wait, I should already have it. Do I want to make that public? I'd rather not. Not public, but global. Gets the first dimension size, the second dimension size. Okay, awesome. Up dot length 0 plus j equals So we only need to go if well, we're going to want to extract those. But we only want to even check if we're on the outer rim, which means that either I equals 0, j equals 0, I equals the largest index of the row, or j equals the largest index of the column. So int max call index map dot get length +1. These will actually be the same, but let's assume that it's possible to get a oblong spiral. Okay, so if this is a row that we need to check, then if map ij equals our target number, return new point ij. Just send an empty point if we don't get anything. All right, so now we need to figure out how to solve this floor problem. Floor decimal, floor double, ambiguous. Double, decimal, ambiguous. Automatically truncates. Okay, that works. So because we're dividing ints, it's going to ignore the decimals anyways, which is essentially 4. All tests passed, and it's giving us 280. But we're on the wrong problem. And we failed. Okay, why did we fail? So we got 3, 2, and 31. This one worked out fine. Okay, so let's map this out. So we should have a scenario. Wait. We're not actually filling in a spiral. Yeah, we're not populating this. How are we getting anything as a result? Get target index. Okay, rather than this, let's make create spiral. Right. Okay, so how do we create a spiral? So we do know we want to go in the middle, then right, then up, left. So we could make a drone to just sort of navigate this map and drop the next number each time. Is there a better way? Oh, we're also map size. No, that's fine. So if it's 9, 3 times 3 is greater than or equal to 9, so we return 3. Yeah, okay. Drone seems simple, but it'd be a lot of extra code. Let's take a quick look at our example here. See if there's any obvious trends we notice about it. Nope. Drone it is. All right, so what are we going to need for that? First of all, for in 0, oops. 9 plus plus. Let's just initialize everything to 0 for now. Okay, so what I'm thinking here, we're going to set up a loop, and we're going to have a drone that knows the current direction it's heading. And so it's going to move right and check if there's an empty spot above it. If it is, then it'll start moving up, and it'll start checking to the left. It'll keep going until it finds that there's nothing to its left, so it'll turn left, then it'll turn down, and then it'll turn right. So point drone position, point midpoint, drone facing, facing dot right. And int next number equals 1. So let us set up our enum. So we've got facing right, and then we're going to head up. We're going to head left, and then we're going to head down. Okay, so what do we do from here? We're going to need a function to drop the next number. Let's take these out because we're going to need to know about this. Okay. All right, so we can have a function that is going to be step. That's going to check the facing. First of all, it's going to put down the next number, so we need to put that in. It's going to take a step forward, and then it's going to check if it should turn. And if it does, it'll update that. And this step will return a bool, so that we know that there is a legal move to do. We're also going to need to know the map. first of all, map dot drone position dot x, drone position dot y equals next number. That's the first step. And then switch drone facing. Forward. We'll get back to that. And then check for turn. So we need to know the map. And then we return true. But before that, we need to make sure that okay, yeah, and if drone position x is less than 0, which means we're getting out of bounds. Let's just pass in our map size here, because we're going to need to know that. Size is greater than or equal to map size. Oops. Or drone position. Actually, we're going to want to extract this to global, because that way we know that it's going to be updated. We could pass it in as a reference value, but I don't want to have to deal with that. Oops. Map in. This is getting all kinds of out of control. Oh no, this was a simpler solution to that problem. Alright, so we've got a global map, and when we create the spiral, we are going to get the map size and the midpoint. We are going to make a new map of that size. We're going to fill it up with zeros, and then we're going to build our drone, and it is going to step through the spiral process and fill in that map as we go. In which case we do not need this. But we do need map size. So case drone feet. Oh, we don't need that. We need right. Then drone position dot x plus plus. Down. Okay, good. So it's going to change our drone position. Check for turn. Map. And actually, we don't need that. This map is global. Alright, so we need to have the drone facing again. Let's just copy this. So if we're facing right, we have already moved. And what we need here is if map dot drone position dot x drone position dot y plus 1 is greater than or equals 0. Then drone facing plus plus. Actually, let's make it more explicit. Up and -1 y. Oops. Let me start going left. Start going down. And then we start going right. Okay, so are we going to start running into any problems? So, right. So is it going to check out of bounds with this? So if it's going right and it's looking up, then it's not going to run into anything out of bounds because we're going to walk off the map before we find null. Yeah, it looks like it's always looking inwards. Alright, so let's check back here. Stepping, checking for turn. Create the spiral. Let's see if what breaks. Expected 31, got 32. Carry 31 steps. Okay, let's print our spiral in that scenario. If I equals 0, I is less than map size. Console. No, I don't need to do that. Console.write map ij. Wow, what is happening here? So 1, yeah, that's 0. That makes sense. We got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, yeah, and that's 17, 18, 19, 20, 21, 22, 23, 24, 25. Got it. If it's 23, that's the same spiral. And 1024 gets really big. Let's see if we can maybe improve the formatting a little bit. Oops. That doesn't help. What even is this? So it looks like when we get really, well, 1020, no, 1024 broke, that's right. Well, it's giving us the wrong number. I can't parse through that quickly enough. is it doing weird things? Okay, how big should 1024 be? So what's the biggest square? 1 equals 1. 100 equals. That's much too big. 50 equals too big. 40 equals. Getting there. 25, 75, 3 is 15, 3 is 1. Four is 16, plus 3 is 30. 3 times 4 is 12. 1. 2 times 3 is 9. Wait, how did I get there? 4 times 4 is 16. 4 times 3 is 12. 3 times 4 is 12. 3 times 3 is 9. Plus 990. We add the 9 there, that's 8. At any rate, it should be about 34 large. Input's correct, right? 10, 24, 31. Result is 32. This case is hard to debug. Times 32, 64, 60, 1024. Okay, so 32, yeah. 32 squared is 1024. answered. $155.33. But we should have gotten 32. Oh, but right, we're only doing odd numbers. So that's why we're going to 33. Now let's see what number it should think it's at. Zero, 3, 3. Got 3. What is this? Failed in part 1. Why are you not putting out our point? It's because this never equals? It does. Okay. So we never equal the target number with this. Because we're only checking the outer one, but since we're rounding it up to odd, it might be in an inner circle. No. Well, no, even then it should always be on the outside, so that wasn't it. That was dumb. Here it is. All right, let's clean up these debugs. Day 3, part 1, 4:30. Correct. Okay, as a stress test on the system, the programs here clear the grid and then store the value 1 in square 1. And in the same allocation order as shown above, they store the sum of the values in all adjacent squares, including diagonals. So the first few squares values are chosen as follows. Square 1 starts with the value 1. Square 2 has only one adjacent field squared, so it also stores 1. Square 3, Fibonacci, no, not Fibonacci. Square 2 only has one adjacent field square, so I thought it said it counts. Okay, square 2 is this one, has only one adjacent field square, so it also stores 1. Square 3 has both of the above squares as neighbors and stores the sum of their values, 2. All 3 of the aforementioned squares as neighbors, 4, 5. Once a square is written, its value does not change, therefore the first few squares would receive the following values. The first value written that is larger than your puzzle input. Okay. So we're going to have to make a different kind of spiral. Okay, so we extract this out. We stop our code, then we extract that out to its own function. This is the behavior that we need to swap out. This is not going to return anything. Run. Let's make these ints. Okay, let's confirm that works still. Good. us get our test input before we go too far ahead. Kill 800, should return 806. Actually, that is larger, so let's do 747 returns 806. Got it. So it's going to put down 1, and then it's going to move us. Yep. So we're going to be in the new position at this point. So surrounding sum. So drone position X. Map size. Int X, int Y, and int map size. For int I equals 0 is less than 2, less than 3. I plus j equals 0, j is less than 3, plus. Surrounding sum is going to equal 0. Okay, so our edge cases are when I or j equals 0 and I or j is equal to map size minus 1. 0 or then we're equal to map size is less than 0 or j is greater than or equal to the map size. Continue. Surrounding sum plus equals and we also don't want to include the middle, so I equals j equals 1. Where's my AND key? Plus equals map I and then return surrounding sum. Alright, so we need to get the part down here. We don't actually need to finish a spiral when we do this, and in fact that's going to be a bad idea. So actually, instead of all this that I just did, take this out. Switch. Create spiral. Why is that complaining? We don't need part anymore, that's why. Int create some spiral until map size midpoint number. Oops. Next number. So what do we do here? We're also going to have a much bigger map than we could ever possibly need. But that's going to be fine for this input. Let's get surrounding sum. If next number is greater than the target number, turn next number. next number. Well, next number is less than or equal to target number. Step. Okay. So we have gone and done nothing. There's value should be 2. So we did 747, 6. Okay, so it is getting 747. It's ticked to 0. Okay. So we need to step. Got that. So it sets our current number to 1. And we should move. Get surrounding sum. Okay, so this must be incorrect somewhere. Yes, that's where it is. So it's one. Drove position x plus I. Drove position dot y plus j. Oops. 0 does not equal 1. And we don't want to continue. reverse all of these. So if our target is 0 or more, that's less than map size, 0 or more, and less than map size, and I and j do not equal 0, let's try that. And right, we don't want those, we want got it. All right, and we're out of puzzles. Well, that's going to do it for today. Thank you everyone for coming on out. We will be coming back to Danganronpa 2 this Tuesday at 7:30, and we will be resuming these puzzles on Wednesday at 8 o'clock.